Consider the Hamming distance function defined in example 7.1.10. Part A, find h of 10101, 00011. Now, the Hamming distance function is defined here. This says define a function h from s sub n cross s sub n to the non-negative integers as follows. For each pair of strings, s comma t, s and t are strings in this case, which are elements of s sub n cross s sub n. This is just saying that this is an ordered pair where the first element is a binary string of length n and t is also a binary string of length n. Then h of s comma t equals the number of positions in which s and t have different values. Now, this whole thing is called a function definition. There are a lot of components to a function definition. For example, first we have this thing in front of the parentheses, which is called the name. The name of this function is h. Now, the input here, I would put an extra set of parentheses just to clarify that s comma t as an ordered pair as a whole is the input of this function. So I think it's better to think about this function where the ordered pair s comma t is the input of this function. But this is usually just written this way, h of s comma t. So s comma t represents an ordered pair, which is the input of the function, and it comes from the domain. And our domain is s sub n cross s sub n, which just means that the first element here is a binary string of length n, and the second element is also a binary string of length n. Lastly, we have the rule of the function. The rule of the function tells us how to find the output. Now, in this case, the rule is presented in plain English, which may seem a little weird, but this is perfectly normal in mathematics to have a function definition with a rule that's written out in plain English. You could write rules in many, many different ways. Now, to find the output here, we need to identify the number of positions in which s and t, in this case our s is the first coordinate here, and t represents the second coordinate here. So we need to identify the number of positions in which s and t have different values. What we can do is we can circle the values where they're different, like this 1 and 0 here, and this 1 and 0 here in the middle position, and this 0 and this 1. So when comparing these two bit strings, we notice that 3 of the positions have different values. And we can do the same thing with this other input. We can compare these binary strings and notice that these entries are different and these entries are different. So 2 positions have different values. And so these are the outputs. Notice these outputs are non-negative integers, which means that they're not negative. Thanks everyone, and I'll see you in the next video.